place to write down is this. So we will be dealing with an equation that looks like this today. All right, so we will be dealing a lot with quadratics in real life. These are a lot of questions that are dealing with physics. Tell me if you guys can fill in the blank here. What goes up must come down. How do you guys know that? If something goes up, what makes it come down? All right, it's gravity. And this is just a general equation that you use. And also think about this. If you start with something, whatever goes up must come down. What shape is that? I'm going to say, is that a parabola? So whenever we are dealing with quadratic equations, typically we are always dealing with positive numbers, because you can't ever have a negative height or a negative time. And so these two values here are the solutions by doing the quadratic formula. And then this maximum point right here, you actually just find the vertex. And so we are going to read through some questions, and we will decide based on reading the questions, are we finding the solutions or are we finding the vertex? And there's a couple things that you need to know. If these numbers will be given to you, V is always velocity, and S, you are going to see the words initial or the starting height of something. And so we are going to have some problems where you might have an object starting from a certain height, and then it's going to go up, and then it's going to come down. And so everything that we are dealing with in these next couple days are dealing with real life situations. But the very first example I want to do is number 1. So you guys can see that question on your screen. I'm going to project it up here. All right, so it says the Empire State Building is 1,250 feet tall. And it says an object is going to be thrown upward from the top of the building at an initial velocity of 38 feet per second, and the height S is going to stand for seconds after it's thrown, is given by the equation. And it says, how long will it take for the ball to hit the ground? So if you guys are looking at this particular question, let's think about this as a picture first. All right, so I don't know the official shape of the Empire State Building, but this is the Empire State Building right now. I'm just going to draw a little picture just to show you what's happening here. All right, where are we throwing the object from? From the top of the building. So we are throwing an object from the top of the building. Now what's going to happen to the object when you first throw it? Does it immediately fall, or does it go up a little bit when you throw something? Yeah, so it's actually going to go, starting from here, the object is going to go up and then eventually down, and then it's going to hit the ground, right? So I'm going to draw the ground here. So the first thing I want to know is, how tall was this building? How tall is the building? It tells you. All right, 1,250 feet. And do you see 1,250 is that last number? Because we said that that value that was going to be added at the end is our initial height. Then it tells us our velocity is 38 feet per second. And then the negative 16 is just a constant. That's actually the factor of gravity that always has the same amount of downward pull. That's why it's a negative 16. And so we have this equation. So right here, the height is 1,250. Now what's the height when it hits the ground? How many feet? How many feet is the object in the air if it's on the ground? 0. So we have an equation here of negative 16s squared plus 38s plus 1,250. It says, how long will it take for the ball to hit the ground? That tells me when it's at the ground, the height is 0. So we're actually solving, we can plug in 0 for height. All right, do you guys see an A, B, and a C there in this equation? So on this one, we are finding out when it hits the ground. Anytime you see something where it says like how far will it take to hit the ground, we're going to be solving with the quadratic formula. So we do have an A, B, and a C value. So at this point, we can find, if we do the quadratic formula, we can solve this. All right, what am I going to plug in for negative B? If B is positive 38, what goes in here for the opposite of B? Negative 38 plus or minus. Now, inside the square root, we are going to do 38 squared and then negative 4 times 38 times C is 1,250. Oh, and I did A. Sorry, negative 16. I plugged in the wrong number. All right, and then the bottom 2 times A, 2 times negative 16. All right, so this is where you guys have your calculators. So let's simplify this a little bit. All right, let's go inside the square root first. 38 squared. So if I take 38 squared, I'm getting 1,444. All right, so 38 times 38 is 1,444. Now, if you look here, I see 2 negatives. So that's going to turn into a positive. So now we just need to multiply 4 times 16 times 1,250. What do we get there? 80,000. And then we're dividing by negative 32. All right, so I'm going to go ahead and add these. The 80,000 plus 1,444 to get 81,444. All right, now do you think I really want you guys to cake this? You know, say, today, decimals are okay. Is it okay to have a 0.5 seconds? You know, say, we are going to, today, we are going to just use the square root button on our calculators to find a decimal. So for those of you that have the Google calculator up, it looks like this. So if you can see, I'm going to zoom in just a little bit. You do have a square root button right next to the 1. So you would just type in square root of 81,444 and then hit enter. And it's going to give you the square root of that. We're going to round to the nearest tenth. So we know 285.3, but the next number, does it stay 0.3 or do we round up to 0.4? All right, let's round that to 285.4. So we are looking at negative 38 plus or minus 285.4 divided by negative 32. All right, so with the quadratic formula, we always get two answers. One time by adding and one time by subtracting the numerator. So let's go ahead and add first. Negative 38 plus 285.4 divided by negative 32. So we want to add that numerator first. Let's see. Negative 38 plus 285.4 is 247.4. And if I divide that by negative 32, it gives me an answer of negative 7.7. So that's our first answer. Now our second answer, and again we're still using the same numbers, but this time we're taking negative 38 minus 285.4 divided by negative 32. All right, so let's see, we've got negative 38 minus 285.4, which gives me a negative 323.4 divided by negative 32, and it gives me 10.1. And it told us earlier that our time was in seconds, so we can go ahead and label those. So on this question, we have two answers here, but there's only one that makes sense. Which one do you think we should go with? We're talking about the amount of seconds it takes for something to start from the top of the building and drop down to the ground. Which answer makes more sense? You're going to say the positive answer. You're going to say it's never going to take you a negative amount of time. So that is one thing that we want to look at. You don't always have to have, you're not always going to accept two answers in a real life situation. The negative answer, there's no way we can have a negative time. So we're not going to worry about this answer because we only want something. If the answer is talking about time, you can only have a positive time, you can only have a positive height. And so I do want to show you guys on Desmos how this works. You guys don't have to open this up. This is just for me to show you. So if you look at this equation on Desmos that we solved, we've got, I'm going to say Desmos doesn't know H's and S's, so I'm going to use X's and Y's just like we did. All right, so if you see that, we're going to have to do some zooming out in order to all right, so if you see here, it's a very, very, very skinny graph. And do you see how it has a starting point at 1250 and then it goes up just a little bit? So I do want to show you guys this vertex point that we're looking at here. The x coordinate is 1.88 or 1.188. This vertex up here, this is actually the highest point. That is telling you on this graph, it takes 1.1 seconds, and it's actually going to go up to 1,272 feet. So when that object is thrown, it starts out at 1250 and it ends up at 1272. How high did that object go up in the air before it started dropping? If it starts out at 1250 and ends up at 1272. How many feet? Yeah, it's 22 feet. Do you guys think that seems reasonable if you just go, like, maybe, do you guys think underhand throw or an overhand throw for this one? Well, can you? So it just depends, but this one has a little bit of force going with it. But so it takes that 1.1 seconds for that to go up, and then it starts to drop down. And then it, if you can see down here at the bottom, along the x-axis, there are two spots where it crosses. And I don't know if you guys see, one of them is a negative answer, negative 7.7. That was the answer we didn't want. But then there's the 10.1. So the solutions to the quadratic formula are always on the x-axis. But whenever you're dealing with a real life situation, you really only need to look at the positives. And I'll say, what do you guys think? So we're still doing the quadratic formula. It's just with a little bit bigger numbers today. And whenever you're doing the square root button, just round to the nearest tenth. Now, I do want to show you guys this to save you a little bit of time. So if we go before we simplified this, I do want to show you that you can actually on your Google calculator just plug all of this in, but I want to make sure I'm 38 squared minus 4 times negative 16 times 1,250. So, do you see how everything that I typed in, you can type in on your Google calculator the entire quadratic formula, and it'll go ahead and simplify that for you. So I am totally okay today on your work if you are using a calculator that has multiple functions. If you guys want to go from here directly to this, I'm okay with that. Now, if you want to do your square root by hand as much as possible, you can. But if you would like to take your square root and just type it all in at once, I'm okay with that as well. All right, you guys are super quiet. I'm gonna say, can you guys at least give me a thumbs up if we're okay so far? All right, now we are going to jump around. So let's see. Oh, I'm not ready for that one yet. Let's go to number 4. All right, so on this one, it is telling you a ball is thrown upward from the ground, and it tells you the height in feet is given by the function. So this is telling you h stands for height and t stands for time. And I am actually going to make my t's with a little tail on them just so they don't look like plus signs. All right, now on this next question, so if we are starting here, it's actually telling us, this 3 tells me that's my starting height. So it's telling me that the ball is starting 3 feet in the air, and it is going to go up, and then at some point in time it's either going to get caught where it started or it might hit the ground depending on the situation. But I want to know the maximum height. Where is the maximum height at? I'm going to say, somebody go point. Where is the maximum height on this picture? If I say maximum, what does that mean? All right, it's at the very top. So this is the point we're looking at for the maximum, right? You'll say, what is that high point called on the graph? It's the vertex. So anytime you are asked about a maximum height, you are actually going to use this equation and find the vertex. So if it tells you maximum height, that tells you to find the vertex. All right, so to find the x-coordinate of the vertex, we do negative b over 2a. And here we've got an a, a b, and a c, so we're going to do negative 64 over 2 times negative 16. What is 2 times negative 16? Negative 32, and 2 negatives are going to divide this into what? Positive 2. And so then the y-coordinate, we're going to plug that in. All right, so again, you can do this by hand, but do you think I care if you go to your calculator and you just type this in? I'm going to say, I'm all about time saving today, so if you guys want to, I don't know why it's not just clearing it. Okay. You guys can type it in like this, negative 16 times 2, but then you got to make an exponent, and then plus, oh, hang on. You know, say you got to just keep typing on this calculator. All right, I got 67. And if you did this, this would be negative 16 times 4, which is negative 64, plus 128 plus 3, which is 67. So you guys can either do the work there or you can use your calculator, but our vertex is 267. Which one do you actually think, which one of these coordinates do you think is the height? Do you think it's the 2 or the 67? All right, so it started out at 3 feet, so would it make sense that 2 is the height? No, on this one it is 67 feet is the maximum height. What's that 2 mean? It's not the distance. So we are measuring 2 things here. The height is the y-axis. What's the t represent? The time in seconds. So what this is telling you is that it takes 2 seconds for that ball that's being thrown to reach 67 feet. So it takes 2 seconds, but this one just says what's the maximum height, so we're just looking for the height, which is 67 feet. All right, so if it tells you the maximum height, you're finding the vertex. You say if it tells you that the ball reaches the ground, what are you going to find the vertex, or are you going to do the quadratic formula for that? Say we just did that on number 1. Yes. So if it says hit the ground, do quadratic formula. If it says maximum height, find the vertex. We have to read the questions. Oh. Oh, let's just jump down to number 9. I like it. I really like kangaroos, and I don't know why. They're kind of mean. Has anyone ever, seen kangaroos box? No, there is a place in Illinois, and they actually have an kangaroo experience, and you can actually go in and play with kangaroos. We did it a couple summers ago. It was super fun. All right, so this question is talking about a kangaroo. All right, so everybody just show me with your hand or your finger, how do kangaroos jump? I'm going to say, all right, Gracie, do that again. All right, so they jump like this, right? It's just little parabolas. They're not jumping like tons of feet in the air, but they're quick little parabolas. So they still have that arch shape, but it's just not as, we're not going like the height of a building and going down, but it's going to have that shape of a parabola as well. So we have an equation that's modeled by this kangaroo jump. All right, so on this equation, I only see 2 numbers. Which one's missing, A, B, or C?
Looks like C.
All right, looks like C. So if it's missing, C is 0, right? Why do you think C is 0? Do you remember on the very first example we talked about the height of 0 represented this? Where do kangaroos jump from? They start on the ground and they end on the ground. So that's why the C is 0. The starting height is the ground. So on this one, it first wants to know how high can a kangaroo jump and how far can a kangaroo jump. So if we are looking at, think about it like X's and Y's on a graph, a kangaroo is going to jump like this, right? So for part A, how high can a kangaroo jump? Do you guys think we're going to do the vertex or the quadratic formula here? All right, we're going to find the vertex. How high something can go is the vertex. Now when it says how far can it jump, I want to know the distance from here to here. Are those points both on the x-axis? So these are the solutions. We're going to find out these 2 numbers, and then we're just going to find the difference between the 2 to find out how far it jumps. All right, so the first thing we want to do is we want to find the vertex of this equation. All right, so the negative b would be negative 0.8, and then 2 times negative 0.0267. All right, so I'm going to use my calculator. I don't want to jump back and forth. So let's see, negative 8, or I'm going to multiply the bottom first. So the bottom, so that's negative 0.8 divided by negative 0.0534. So I just multiplied my 2 numbers on the bottom. Now I'm going to divide. Negative 0.8 divided by negative 0.0534 turns into a positive 14.98, which what would 14.98 round to if we do the nearest tenth?
15.
Yep. So this is really, really close to 15. So then define the y. We're going to plug that in. Negative 0.0267 times 15 squared plus 0.8 times 15. All right, so I'm going to try to get out of the light, but I just typed everything in, hit enter. You guys can use your Google calculator to type everything in, and I got 5.9925, which is really close to what? 6. All right, if we round it to the nearest tenth, it is 6. All right, so if we look at this, which one is how high it can jump? Is it 15 or is it 6? So if you look at the x-axis, the x-axis is representing the distance traveled in feet. So this is how far it travels. Y is the corresponding height. So how high can a kangaroo jump? Would be 6 feet. So that's telling us here this is 15.6. So it said when it jumps up, it also jumps over. So it's going 6 feet up in the air but 15 feet across. Now, we can do the quadratic formula, but I just want you to think about something. Aren't parabolas symmetric? So if it, at its highest point, it's traveled 15 feet here, how much is it going to travel on its way down? So how far do you think it's going to jump? Huh? 30 feet. So the height for how far it can jump 30 feet. So I'm going to say 6 feet high and 30 feet for distance traveled. Now, could you do the quadratic formula and get 30 feet as well? All right, so my last one for the day, we're going to go to number 3. And I actually want you guys, and if you guys want to work with somebody on this one, but I want you guys to look at the order of this equation. Is it in the correct order as far as like A's, B's, and C's? You know, say, what do we typically like to see with, what term do we like to have first? A, which is the t squared. The first thing I would do on this right here is I would change it to this. It's a negative 16t squared and a 56t. So here's a couple things. If it says maximum height for part A, what are you going to be doing there? All right, on part A, you're going to find the vertex. Now on part B, this is something we've not done yet, but I hope that this is something that I'm really hoping you guys can do without me, but we will go over it. When it says, what is the height of the ball after 1 second? Is 1 second a height or a time? All right, so on this one, you're going to plug in the value 1 for which variable, h or t. You're just going to plug it in for t. And then the last part, after how many seconds will it return to the ground? This is where you're going to do the quadratic formula. So you guys compare up, and I know that we only have about 5 minutes left, so I don't know if you guys maybe want to divide and conquer. Maybe some of you do the vertex, some of you plug in 1 for t, some of you do the quadratic formula. But I'm going to give you guys some time to work on this. I'm going to freeze the screen, and then here, before the bell rings, I will give you guys the solution. All right, so I know time is running short, but I do want to show you guys, if you did the vertex, I didn't round, but if you rounded, you should have something really close to this. And when you did negative b over 2a, you should get 1.75 or 1.8. Plug that in, you should have something around a maximum height of 49 feet. Then when you plug in 1 for t's on this, we get 1 squared and then 1 here times 56. So that ends up negative 16 plus 56 is a 40 feet. So after that first second, it takes 1.75 seconds to hit this. So this is on its way up, so it's a little bit less. And then the quadratic formula, your two solutions are 0 and 3.5. So then that tells you, we definitely go with the one that tells you how far. It doesn't take 0 seconds. So you guys have an assignment for the next 2 days. So for the worksheet, if you guys see on Tuesday, which is today, we're doing the odds. Tomorrow, you're doing the evens. So instead of giving you guys 2 separate assignments, I'm just giving it to you in one document and just do everything for 2 days. You know, say if you guys need me, I have meetings in the morning, but I should be good to go after 9 tomorrow.